Hello everyone. In this video, we are going to look at a previous exam paper and we're going to focus on the chapter of transverse waves. Without any waste of time, let's get right to it. The first question that we have, it says, study the two transverse waves, P and Q, as shown below. So if you look at the diagram that we have two waves. But now the solid wave is going to be P as it is indicated here. And a dotted wave is going to be wave Q as indicated. So in our diagram, we are also given a length from B to D, which is 100 millimeters. We also have this time of 1.5 and the time of 3 seconds. So that is what we have now in the diagram. So after identifying what we have in the diagram, we can now start to answer the questions. So the first question that we have, which is 6.1, it says, write down one difference and one similarity between wave P and Q. So now, what is it that is different between these two waves? So we can see now the wave of P, it is having a very big amplitude than the wave of Q, because they don't have the same maximum point, and then they also don't have the same minimum point. So the difference will be the amplitude. So the amplitude is different in both the waves. The amplitude of P is bigger than the amplitude of Q. So the question also said we must write down the similarities that we have in these two waves. So what is it that is similar in the two waves? Remember now, we have what we call a period. So do you see now, both this wave, they have the same period of 1.5. And a period is just a time to complete one wave. So the wave of P here, it is completed at 1.5 seconds. And then also one wave of Q is completed in 1.5 seconds. Remember, when you talk about one wave, we just talk about one complete cycle. So do you see now we have half of a cycle at the top and half of a cycle at the bottom. So when we combine those two, we're going to have a complete cycle. So they have the same period, the same time it takes to complete one wave. So we are going to say, okay, the same thing is what? Is the period. So automatically when they have the same period, they are going to have the same wavelength, because the wavelength is just what? It's just the entire distance to complete one wave. So they're going to have the very same distance as they have the same period. So you can also say, okay, the wavelength is also similar in both these waves of P and Q. Okay, so now if we move on now to the next question, which is 6.2, they say for wave P, write down 2 points that are out of phase. So when you talk about the points that are out of phase or the points that are in phase, we are actually referring to, if we look at point A is about to go down as the wave is going to the right. And then now this point of B here is about to go up, and the point of C is about to go down, and the point of D is about to go up. So when we talk about the points that are in phase, we talk about the points that are both going down or the points that are going both up. So that means the point of A and C, they are going to be in phase. And then also the point of B and D, because they are both going up, they are going to be in phase. So now when we talk about out phase, we talk about the points that are going in opposite direction. So if we look at the point of A is going down and the point of B is going up. So this will mean what? The point of A and B, they are out phase. Or you can also look at the point of C and the point of D. C is going down, D is going up. So those 2 points, they are out phase. So the question said we must write the out phase point. So now I can see now, okay, A and B are out of phase. Since A is going down, B is going up. And then C is going down, D is going up. So both that are out of phase. So as we move on to the next question, which is question 6.3, it says, define the term frequency of a wave in width. So we know that a formula of frequency is 1 over period. So by definition, frequency simply means how many waves do we have in a second. So if we have 1 wave in a second, that means we're going to have 1 frequency. If we have 2 waves in a second, we're going to have 2 frequencies, which is 2 hertz. So if you want to define frequency by width, you can just say number of waves per second. Number of waves per second. So if I can just try to prove this to you on the equation, do you see now if the period was, in case here, not 1.5, but it was 1 second, what will be the frequency here? So the frequency will just be 1 over 1, since the period is 1, so the frequency will be 1 hertz. So do you see now, we are just having 1 wave in 1 second. That is why we have 1 hertz of frequency. So the frequency simply means how many waves do we have in a second. So the next question, which is 6.4. In 6.4, they say now for wave Q. So now we are going to look at wave Q. They say now we must calculate the frequency of the wave. So we know that, okay, this is wave Q here. And then wave Q, it is also having the same period of 1.5 as wave P, because the period is just the time it takes to complete the second. We have already explained that. So to determine the frequency of wave P, wave Q, we're just going to say frequency is the same thing as 1 over period. So now to get the frequency, we're going to say 1 over 1.5, and therefore we're going to get the frequency of wave Q. So the frequency is 0.67 hertz. So the last question that we have, which is 6.4.2, they say we must calculate the speed of the wave. So remember, if you talk about the speed of the wave, the equation is speed is equals to the distance over the time. But if it happens that we have what? The wavelength, we're going to say the velocity is the wavelength divided by the period. So if we can try to analyze what we have here in the diagram, we can see we have the distance of 100 millimeters, and then this distance is going to be the wavelength, because it is the length it takes to complete what? To complete 1 wave. So look at this, it's going to be half of a wave here at the top, and then we're going to have a quarter of a wave and a quarter of a wave. So do you see now this distance, it covers a full wave, because if you have a half and a quarter, it makes 1 second. So that is why this 100 millimeters is going to be what? Is going to be the wavelength. And we already have the period, which is 1.5. So now to determine the speed or the velocity, we're just going to substitute now the wavelength. But now this wavelength that we have here is in millimeters. So we must first get it to meters. So you're just going to say 100 divided by 1000. So when you substitute it on your equation, you must substitute it in meters. So it's going to be 0.1, and the period was 1.5. So now if we say 0.1 divided by 1.5, we are getting that the velocity of this wave is 0.067 meters per second. So the velocity or the speed is the same thing. I can see now they said we must calculate the speed, and I keep on saying velocity, but I hope you do understand. So thank you very much. That is all for this video.